Let's imagine erasing the most famous feature in the solar system. In a fraction of a second, the defining halo around Saturn vanishes into vacuum. What just disappeared was a colossal sheet of debris, stretching over 270,000 kilometers wide, but remarkably thin, averaging only 10 meters deep. It was composed of 99% pure water ice, the pulverized remains of an ancient, shattered moon. While an instantaneous vaporization is science fiction, a slower version of this erasure is happening right now. Observations from ground-based telescopes like the Keck Observatory in Hawaii, seen here, measured a massive, continuous flow of water ice draining directly from the rings into Saturn's upper atmosphere, a phenomenon known as ring rain. Based on the volume of this steady downpour, along with data from the Cassini spacecraft, we know exactly how much time the rings have left. In less than 100 million years, the entire system will be gone. These brilliant bands of ice are a temporary, highly active planetary organ, a fleeting display that humanity happened to witness at exactly the right moment in astronomical history. If we fast forward that decay and watch the rings vanish today, the immediate consequence would be a massive optical shock. From Earth, Saturn's visual brightness would instantly drop by 2.5 times. That severe dimming happens because of the ring's geometric albedo. The sheer surface area of all that pure water ice acts like a cosmic mirror, reflecting a glare so intense that it masks the true, dimmer nature of the planetary disk. Without that overwhelming scattered light blocking our view, astronomical instruments would suddenly have a clear, uninterrupted line of sight into the space immediately surrounding the planet. Looking at this map of the Saturnian system, we can pinpoint exactly what would emerge from the darkness. Tiny sub-kilometer moons like Pan in the Encke division and Daphnis and Atlas near the outer edge of the A-ring are currently embedded within the ice. The rings act as a massive optical shield. Removing them strips away that cover, exposing the vulnerable, hidden architecture of the inner satellite system. A month after the disappearance, the effects would reach Saturn's climate. Normally, the physical structure of the rings casts enormous, shifting shadows across the planet's atmosphere, especially around the equinox. This heat map shows the atmospheric tension. Shaded regions cool while exposed areas heat up, creating a sharp boundary that drives violent wind currents. Without the ring shadow, the planet receives uniform solar heating. Temperature gradients flatten and turbulent winds stagnate. The night side of the planet suffers an opposite fate. Normally, the highly reflective ice scatters sunlight onto Saturn's unilluminated hemisphere, providing a subtle warming effect. Without that reflected glow, the night side faces severe, steep radiative cooling. By acting as a shield by day and a mirror by night, the rings function as a massive planetary thermostat. Erase them, and Saturn's dynamic weather systems stagnate into a simpler, homogenized state. A year into this ringless reality, an invisible electromagnetic disaster takes hold. Right now, the space beneath the A, B, and C rings is the most radiation-isolated, low-energy zone in the solar system. High-energy plasma and cosmic rays traveling along Saturn's magnetic field lines are physically blocked, absorbed by the rings like a sponge. Remove that barrier, and the floodgates open. Electrons and protons surge inward, relentlessly striking Saturn's atmosphere. This constant, intense bombardment triggers a process called radiolysis on the surviving inner moons. The radiation directly impacts their icy surfaces, chemically stripping away water molecules to generate tenuous atmospheres of molecular oxygen. The rings serve as the physical immune system for the inner magnetosphere. Without them, the space around Saturn becomes a highly irradiated hazard zone. A decade later, the gravitational architecture of the entire system begins to collapse. Moons and rings are connected through resonant torque, a mechanism where the dense rings constantly transfer angular momentum to the satellites, physically pushing their orbits further out into space over time. Satellites like Prometheus and Pandora rely on this interaction to survive. These shepherd moons constantly plow through the icy debris, gravitationally pulling and scattering the material to clear gaps while maintaining their own orbital momentum. Without the immense mass of the rings, that resonant torque instantly drops to zero. The outward migration of the entire inner satellite system stalls permanently. Bereft of the icy herd they were meant to constrain, the shepherd moons lose their physical anchor. Their paths destabilize, leading to unpredictable, chaotic drift, and a high probability that they will eventually collide with one another. The rings serve as the gravitational engine for the entire moon system. Without them, the satellite architecture collapses into orbital anarchy. What remains is a completely different planet. Saturn is no longer the dynamic master of an interconnected, evolving ecosystem. It is a darker, irradiated, and stagnant gas giant. Understanding this loss gives us a powerful tool. By studying how the rings currently alter Saturn's temperature and atmospheric chemistry, astronomers now have a specific thermal blueprint to help them hunt for invisible exorings around distant exoplanets. Orbital observatories like the Hubble Space Telescope, seen here, are crucial to this effort. They can detect the subtle atmospheric chemistries and Lyman alpha excesses across the galaxy that hint at a gas giant harboring a hidden ring system. It brings us back to our own cosmic timing. If early humans had evolved a few 100 million years earlier, or a few 100 million years later, we would have looked up through our telescopes and seen a bare, ordinary sphere. Saturn's rings are a fleeting, beautiful catastrophe, a dying planetary organ that reminds us of the delicate, temporary nature of our universe. What lost cosmic wonder would you travel in time to witness? Let us know below.